Inheritance and friendship topic is actually not very complicated. If you recall, if we have this base class, right? So this is our base class, and we have a derived class. Okay, and there are two kinds of friendships. There could be some class, we'll call it a friend class, like this. Okay, so there could be a class, the third class that exists in the system. And this is, of course, the derived class and the base class. And there could be some kind of function f, okay, which is just a free function. It's not a member of any class. And so these are the two kinds of friends. And so both class friend or function friend could be declared inside, for example, a base class, right? So there could be declaration of this class could be placed inside the base class, or declaration of this function can also be placed like this inside this base class with the friend keyword. So we basically, so the way it looks like is like friend class f, semicolon. Okay, and this appears to be here. So when this happens, of course, this class will be allowed to access all data members, including private data members of this base class. Same thing with the function, if it's declared a friend. But with respect to the derived, although it looks like we're inheriting everything, we do not inherit friends. So this is no longer a friend of the derived class, and so it's not automatically, this friendship not automatically distributed or made available or inherited by the derived class. So there's really no impact on the derived class. If you want this to be a friend, you have to declare it explicitly. You have to like place these friend declarations in the derived class. And of course, being friend of the derived class doesn't make you a friend of the base class. So these are, because these classes, it's actually just for the sake of simplicity of the environment. So because this kind of friendship inheritance doesn't add much value, you know, I mean, to the overall design. After all, friend is a bit of a breach of encapsulation, because really the ideal encapsulation is like when everything is protected inside each class, and this friendship actually opens the door over here, and so this class all of a sudden can get inside and do things. So that's so this is why it's kind of restricted, and inheritance does not automatically you know, expand this friendship to the derived, to the base class. Now let's talk a little bit about inheritance versus encapsulation. So recall that, again, if we have the base class B, okay, some kind of base right here, so we write this class, and then we decide to derive some classes from it. So D class right here inherits from the base class. At runtime, this will look like the base class will be constructed as an object right here at runtime when we create an object of, say, derived class. And the derived class will be built around it, just like this, right? So this will be box inside box, just like this. So this is the design picture when we write our software and we decide to do things in the base class and decide to do things in the derived class. At runtime, we create the derived class instance, an object of this type, and this is how it's going to look like. So then there is this notion that in this case, we say the derived class is also a base class. So, for instance, a car is a vehicle, a bus is a vehicle, and so if the vehicle is our base class and the car and a bus are derived classes like this, we can safely assume when we see this this design based on the inheritance, those relationships, these arrows that point from the base class to the from the derived class to the base class. So this is, say, a vehicle, and this is the car, and this is the bus, and this is the motorcycle, right? So this is another vehicle, a motorcycle. So this also derives itself from the vehicle. Okay, so in this sense, a motorcycle is a vehicle, the bus is a vehicle, the car is a vehicle. This is what's called is a type of relationship. So the inheritance logically implements is a type of relationship. Remember that the opposite is not possible because of the direction of these arrows. So vehicle is not a bus. I mean, we just like, we don't want to generalize it this way, okay? Instead, but the bus at the same time is a vehicle for sure. It's guaranteed, right? And so this type of arrangement allows us to essentially, if we make this design, it allows us to nest inner class inside the outer class, because they represent the base and the derived class. The same thing can be achieved by simply taking this, for instance, making car class, right, and adding. So this is our car class, okay, a car, all right. And let me just redo it like this. So really, just this thing is a car. Okay, so I'll just write it up the best that I can with my mouse. All right, so this is the car class, and an instance of a vehicle can be added right here inside the car class when we define our car class. Okay, so right here, a vehicle can be added as a data attribute. Okay, just basically add data member to this class inside the car, and this will become, if we instantiate the car, the picture will be the same, right? So we create a car, and it will have a member, the data member inside, which is a vehicle object inside of it, right? So this is it's the same picture. But in case of what we call encapsulation, this is like vehicle is encapsulated inside the car. In this case, the relationship between the outer box and the inner box changes to has a. We say that car has a vehicle. So this is like car has a vehicle type of design. So it's, if you want like diagram of it, so if this is a car and this is a vehicle, so then the design diagram is more like car pointing to the vehicle, because the vehicle is designed independently but used as the attribute inside the car. So this is this type of relationship is not inheritance, and it's more of a what we say has a the ownership, right? So car owns the vehicle. So this is just a little bit of a distinction between the inheritance and containment. All right. So inheritance automatically provides interface of the base class. Containment does not. Right. Encapsulation allows restricting the interface but requires republication of needed parts. So in other words, if we want to make that vehicle available, like functionality of the vehicle available outside of the car, in the second example, then we have to add new functions to make that functionality available. So again, this is no big deal. It should be pretty obvious when you design your classes and the libraries of your classes. And oftentimes we rely on inheritance, inheritance is, for instance, almost like de facto standard for designing graphical user interface, because normally you have some kind of graphical user interface library which has a collection of classes, and you can attach to that library by deriving your own, like using this type of association by deriving your classes from the classes that already exist in graphics library, and this way you can expand them by adding your own widgets and gadgets to your graphical interface, but at the same time having full access to the original functionality of the base class from the graphics library, for example. So this is just a set of observations with respect to inheritance versus encapsulation, or inheritance versus containment, right? Encapsulation or containment of one object inside another. Inheritance and templates. Okay, we've seen examples of templates. Templates are very interesting and very attractive design, a very interesting set of tools. Just remember how we've tried multiple examples using standard library containers, algorithms, and iterators. So overall, inheritance allows code reuse because you inherit everything from already existing class, and therefore we discussed earlier, it's similar to copy and paste from one class to another class. So it's definitely reuse by asking compiler to do that kind of reuse for us. Inheritance implies an asymmetric relationship between classes. So it's definitely that you have the part, one part is the base class, another part is the derived class. And template instantiations are unrelated, because when you write the template, you really don't know how it's going to be instantiated, because the template parameters are data types that may not even exist today. Tomorrow, people will invent new user-defined data types, new classes, new structures, and they will try to make them part of your template class, to parameterize your template class by their own data types. So they're basically much less related. So inheritance is much more observable in terms of prediction, like what combinations of base and derived classes are going to exist at runtime, whereas template is so much more generic. It's just totally, its promise is that it's going to be extremely open to very, very big variety of different data types. So inheritance supports runtime polymorphism, which is yet to be discussed in our conversation about inheritance and virtual functions. And after we complete our set of exercises with inheritance, it should be relatively clear to understand what kind of situation inheritance could be benefiting you pretty well. So, of course, you can combine all of this together. So there's no restrictions. In general, C++ as a general purpose programming language, once you learn a certain technique, like once you learn how to write a loop of certain kind, you can apply that pretty much anywhere else where you can write other code.